Voyager 1, NASA's farthest-flung probe, has had folks hooked for almost 50 years. Since its launch, it's been sending back key info from way out in space, which has really helped us get our heads around the cosmos. Lately, though, Voyager 1 has been acting weird, sending signals that have scientists scratching their heads. These strange signals have got everyone wondering if they're just glitches or if something else is up. Maybe even aliens. So let's check out these odd messages and think about what could be hiding out there. We've always been curious about the universe, and that's what got us to launch missions like Pioneer 10 and 11 back in the day. Voyager 2 took off from Kennedy Space Center on August 20th, 1977, kicking off a big change in how we explore space. Voyager 1 followed shortly after, on September 5th, 1977, starting a trip that would take it past the outer planets and flip what we thought we knew about space on its head. Each probe, weighing around 721 kilograms, like a small car, took different routes at different speeds. Voyager 1 zoomed past its twin on December 15th, 1977, and became super important for learning about the universe, giving us insights that have changed how we see space. Before we get into the recent crazy discoveries, let's look back at some of Voyager 1's earlier wins. Back in 1979, when it was about 265 million km from Earth, it snapped some high-res pics of Jupiter. By January of that year, it had put in 100 hours of observing, making a cool time-lapse video of Jupiter spinning. The 3,750 photos gave us a crazy good look at the planet's wild atmosphere and patterns. Plus, Voyager 1 spotted a ring around Jupiter and found 2 new moons, which upped our knowledge of the planet's system. To stay on track and dodge Titan, one of Saturn's moons, the probe made some course changes. Then, it set its sights past the planets and into interstellar space, flying at a massive 325 million km a year. In January 1990, Voyager 1 kicked off its job of checking out interstellar space, going beyond our solar system's edge. During this time, it did some amazing things, like spotting for more moons Mimes, Enceladus IIs, and Rhiannon, grabbing some sweet photos of the solar system's faraway areas. On February 14, 1990, from about 6 billion kilometers away, Voyager 1 took the famous family portrait, a bunch of photos showing the inner planets. These 60 images were added to the probe's collection, which already had hundreds of pics from hanging out with gas giants. Meanwhile, Voyager 2 was racking up its own achievements. It clocked wind speeds on Neptune at over 2,100 kilometers per hour, the fastest winds ever seen in the solar system. It also checked out Triton, Neptune's biggest moon, where temps dropped to a chilly minus 391 degrees Fahrenheit, making it one of the coldest spots known. Triton seemed to have icy geysers shooting out nitrogen gas and frozen bits as high as 5 kilometers, showing that it's geologically active. These mind-blowing finds really deepened our understanding of what's going on at the edge of our solar system. The Voyager missions have changed the game, showing us unexpected stuff happening on moons we thought were dead. This made us rethink old ideas about their geology. Voyager 2 especially made history as the only probe to visit both Uranus and Neptune up close, which is pretty awesome. NASA kept these old missions going by doing things like turning off systems that weren't needed to save power. The mission is expected to run until 2030, which is a big deal for the teams who've been working on it their whole careers. Voyager 1 and 2 were built to spin slowly, which kept images from blurring while moving. Even before getting to the outer planets, the probes sent back detailed shots of Jupiter, showing swirling clouds and the giant Great Red Spot storm that's had scientists intrigued for decades. One of the most amazing finds was active volcanoes. On Io, one of Jupiter's moons, instruments picked up weird readings, which were then backed up by images showing massive volcanic plumes and a landscape changed by eruptions. One blast was said to be 1,000 times stronger than the Mount St. Helens eruption, covering an area about the size of France. As the probes kept going, they were slowly powered down to save energy for travel between stars. Oddly enough, they didn't get photos of Mercury or Mars because of tech issues. NASA later launched other important missions, including Pioneer 10, Pioneer 11, and New Horizons. On February 17, 1998, Pioneer 10 passed Pioneer 11 as the most distant probe from Earth. Still, Voyager 1 trucked on, and after 14 more years, it officially entered interstellar space on August 25, 2012. A big part of these missions' success was using gravity to slingshot the probes toward their goals while saving fuel. Instead of just using engine power, they used the gravity of planets to speed up and change direction. This allowed them to cross huge distances with less energy. As Voyager 1 neared Jupiter, the planet's gravity sped it up. Good calculations were key to avoiding dangerous changes in direction or speed. Voyager 2 used Jupiter and Saturn's gravity to reach Uranus and Neptune, which also shows how well this trick works. Looking back on these amazing efforts, researchers are excited about what the odd signals from Voyager 1 might mean. The probe is still checking out the area beyond our solar system, and gathering info from the edges of planets like Jupiter, Saturn, Uranus, and Neptune. Voyager 1's time-lapse photos showed 10 volcanic eruptions on Jupiter, spotted more moons, and found a ring around the planet that we didn't know was there. These observations really helped us get a better handle on the Jupiter system. It also found 4 extra moons of Saturn Mimes and Enceladus IIs. And Rhiannon sent back awesome pictures of the planet and its rings, giving us a fresh look at what they're made of. The flybys of Uranus and Neptune gave important details about their atmospheres and satellites, which helped us understand the far-off areas of our solar system better. After finishing up their planetary surveys, the probes headed for interstellar space, where they're still collecting key science data. Ongoing mission broadens our view of what's out there beyond our cosmic neighborhood. As we wait for new details from Voyager 1's mysterious signals, and think about what they mean for how we see the universe, the inspiring voyages of these probes continue to fascinate scientists and space fans around the globe. Look at their findings. Remain super important for pushing human knowledge and stretching the limits of space science. The Voyager missions gave us amazing views of the solar system and beyond, capturing great images and making cool scientific discoveries. Besides the tech stuff, the probes carry a cultural artifact that's meant to tell Earth's story to any smart life forms they might run into. The Golden Record has greetings in 55 languages, music from all over the world, and natural sounds like rain and whale songs. This message in a bottle is humanity's hope that advanced societies might find and understand it someday. Voyager 1 and 2 were kitted out with a bunch of science tools that changed space research. These included magnetic field sensors, plasma wave detectors, and imaging devices, all of which gave priceless data about space conditions. The magnetometers explain the magnetic fields of the outer planets and how they interact with their surroundings. Plasma sensors showed how solar winds affect planetary atmospheres. One of the biggest success stories of the missions was mapping the edge of the heliosphere, an area dominated by solar particles and magnetic forces that surround our solar system. As Voyager 1 neared this frontier, it saw a change from solar particles to interstellar stuff. It's giving key proof about how this boundary protects Earth from harmful cosmic radiation. The probe also found the termination shock, a spot where the solar wind slows down and gets thicker. Beyond that lies the heliosheath, a crazy area where solar and interstellar materials crash into each other, making a rich and active plasma area. Voyager 2's trip added more clarity to our understanding of these outer solar regions, its measurements, especially of Uranus's tilted magnetic field. This challenged old models and sparked new research into planetary magnetism. These missions not only pushed science ahead, but also grabbed the public's attention. The stunning views of faraway planets and the cool stories of the probes have inspired generations. Iconic images like Saturn's rings and Jupiter's Great Red Spot remain some of the most memorable photos in the history of space exploration. To stay on track and not crash into Titan, one of Saturn's moons, Voyager 1 made some course corrections. Then, it was off to explore interstellar space at about 325 million kilometers a year. In January 1990, Voyager 1 started studying what's between the stars, going past the edge of our solar system. It also found 4 moons of Saturn: Mimes, Enceladus, IIs, and Rhea. On February 14, 1990, From about 6 billion kilometers away, Voyager 1 took the famous family portrait of the inner planets. This group of 60 images was among hundreds of photos from encounters. With gas giants, Voyager 2 also did amazing things. It measured winds on Neptune going over 2,100 kilometers per hour, the fastest winds ever seen in our solar system. It also looked at Triton, Neptune's biggest moon, which is super cold at minus 391 degrees Fahrenheit. Triton has icy geysers that shoot out nitrogen gas and frozen stuff up to 5 kilometers high, which is pretty cool. These discoveries really deepened our picture of the outer solar system. Voyager 1 and 2 have been game changers, showing us that moons we thought were dead are actually active. This changed how we thought about their geology. Voyager 2 is also the only spacecraft to ever visit Uranus and Neptune up close. NASA stretched out the lives of these missions by turning off systems that weren't as important to save power, so that they can make it to 2030. Not bad. Voyager 1 and 2 were well-designed machines to make the images less fuzzy. Even before reaching the distant planets, they sent cool shots of Jupiter that showed clouds and the Great Red Spot, a storm that has intrigued scientists for decades. One cool find was active volcanoes on Io, one of Jupiter's moons. The crafts picked up weird data that was backed up by visuals that displayed major eruptions. In fact, one was 1,000x as powerful as our eruption of Mount St. Helens and Blankets, an area bigger than France. As the probes went on longer, they were powered down to save energy for interstellar travel. They didn't snap visuals of Mercury or Mars because of tech restrictions. NASA sent more missions like Pioneer 10 and 11, but on February 17, 1998, Pioneer 10 went past Pioneer 11. Voyager 1 went on to space on August 25, 2012. A reason for these missions' wins came from gravitational slingshot moves to propel the craft. Instead of engine power, they grabbed extra thrust from planets to use as a jump to another place. The gravitational pull increased speed, and the knowledge of the scientists helped the craft prevent going off course. Researchers are rating on clues on these weird signals coming from the Voyager. Voyager 1 is still going beyond our solar system to grab data from the fringes of our planets. Voyager 1 made time-lapse photos that showed some eruptions from Jupiter itself and an unknown ring nearby. It also found 4 moons of Saturn, Mimas, Enceladus, Tethys, and Rhea, snapping imagery for scientists. The flybys of Uranus and Neptune was important to understand their environment. After their survey for the planets ended, probes went to interstellar space to grab knowledge that broadens our view behind the parameters. The travels are encouraging, inspiring, and captivating. Beyond the tech, the probes have artifacts to give to aliens, if they ever show up. The Golden Record has greetings in 55 languages, sounds, and musics. Basically an interstellar message in a bottle. It has magnets, waves, and imaging tools that give data about where the probes are going. The magnetometers helped map the zone that included the solar system, a region of solar wind. The data gave us data on how solar shields the world from radiation, going into plasma and chaos, forming a rich environment. This provided clarity and inspired fresh exploration by other craft. Because of Voyager and the images of planets that has promoted space exploration to generations,